ABC is a right angle triangle, and in part A we need to work out the length of BC, giving our answer correct to one decimal place. So we're trying to work out this length here. So to do this we can use trigonometry. So we've got this little helpful reminder here, SOHCAHTOA. I'm going to use that in a second. Now the first thing I need to do is label the sides. So we've got a right angle triangle, and we've also got one known angle. Whichever side is connected to the right angle and the angle we know, we're going to label as the adjacent side. The side that's opposite the angle that we know is the opposite side, so we're going to label it as an O. And the side that's opposite the right angle is the hypotenuse, so we're going to label that H. Now this side here is the one I want to work out. So we're going to look at SOHCAHTOA here and see what we can do to work out this length that we want to find out. So we know it's got to include an O, so we can ignore this part here. So it's either going to be sine or tan. So we need to look about what we have information about. We have information about the adjacent, but not the hypotenuse. So we can't go with sine because that would have two unknowns, the opposite and the hypotenuse. So we're going to have to go for tan. And what this essentially means is we've got tan of some angle is going to equal the opposite over the adjacent. So in our case, we got tan of 56 degrees equals opposite, because we don't know that yet, over adjacent, which is 12. Well, what is the opposite side? That is the length that we want to work out, BC. Now, if I multiply both sides by 12, I'm going to have 12 tan of 56 degrees equals the length BC. So if I put all of this into the calculator, I'm going to get that BC equals 17.79073 ... But we want that to one decimal place, so that's going to be 17.8. So final answer here is 17.8. So we get 1 mark for our working over here, and 1 mark for the correct final answer to one decimal place. Now for part B, we're told that PQR is a right angle triangle. And we need to work out the size of the angle marked X, giving your answer correct to one decimal place. So again, we're going to use trigonometry. And again, we can use SOHCAHTOA to help us. But this time, instead of working out the length of a side, we're working out the size of an angle. So again, step 1 is to label A, O, and H. So the one that's connected to the angle and the right angle is the adjacent side, so A. The side that's opposite the angle is opposite. And the last one here is the hypotenuse. So what information do we know? Well, we've got some information for the adjacent and for the hypotenuse. So this means we have to use cos, because that uses our information for the adjacent and hypotenuse. So what this means is that cos of some angle is the adjacent over the hypotenuse. So in our case, we're going to have cos of our angle X. It's going to equal the adjacent over hypotenuse, so 15 over 18. Now to get this X by itself, we can do inverse cos. So we can say X equals inverse cos of 15 over 18. And if we put this into the calculator, we get 33.5573 ... However, again, we want one decimal place, so that's going to be 33.6 degrees to one decimal place. So the final answer is 33.6 degrees. And again, we're going to get 1 mark here for working, and 1 mark for the correct final answer to one decimal place.